The last problem we're going to see in this chapter is called cutting stock model, and this can be used in many applications in process manufacturing where you have a continuous product. For example, steel rolls or paper rolls and even carpet. Now we want to cut a continuous roll of paper roll into smaller widths such that wastage is minimum. So here is an example where we have a huge 200 yards long paper roll all wound up in a huge big roll, and that is 60 inches wide, okay, 5 feet. Okay, so that's the stock, that's the manufactured stock. Now we want to cut this into smaller widths to customers, and customers place orders in specific widths. For example, these are the widths in which you normally receive orders: 12 inches or 15 or 20, 24, 30 or 40. Okay, and you have some orders that have come in, so you have to now cut several rolls to fulfill these orders, and we want to make sure that the number of rolls that we have to cut is minimum, so that way the wastage is minimum. So let's look at the Excel file. So width of the roll is 60 inches. So let's give a name. Okay, so that's an input value. And the widths available are these. So these are the widths in which we sell our product. So let's give a name here. Now here are the orders that we have received for those widths. Okay, so these are this is what is required. We'll give a name. Now we want to make sure that we have enough obtained in when we cut these rolls such that this is met, the demand is met. Okay, so now how are we going to do this? Now the setting up of this model is little more complicated than the previous ones that we have seen. What we have to do is to look at all the different ways in which these widths can be cut from a 60-inch roll. So that is patterns. We have to look at all the different patterns that are possible, and for each pattern what the wastage will be. So we have to calculate that. So here we are looking at feasible ways to cut up a roll. So how many 12 inches, how many 15 inches, how many 20 inches, and so on. So our wastage then will be, so width of the roll, okay, minus some product of how many widths we're going to cut in a given pattern with the width of that particular cut. So now we are not cutting anything at all, so the entire thing is waste. Suppose if we cut 140 inch, then we'll have a waste of 20. Okay, so we cut 120 along with that, then wastage will be 0. So that's what we need to set up first. Let's copy this. All right. Now we need to figure out all the unique ways in which we can cut these sizes, and we need to go about this in a systematic way. Otherwise we may end up missing some unique cuts that are there, or we may end up counting the same cut pattern twice. We don't want that. We don't want to leave anything, we don't want to miss any pattern, and we don't want to count the same pattern again. And the way to do this is, okay, any system will work. Now one system is you start from the leftmost side and then you cut as much as possible of that particular size and then move towards the right. So if we start the very first pattern, we can cut 5 of those 12 inches and that will leave no wastage at all. So that is one pattern. Okay. Next you go down, okay, instead of 5 you cut the next largest number possible, which is 4, but actually when you do that you're left with 12 inches of waste, which is actually one more 12 inch. So if you cut 4 of these, that's same as the previous pattern of cutting 5. So 4 is not a uniquely different pattern, so we need to go down to 3. So if we cut 12 inches, that will leave a waste of 24. So now we can cut one of these 15 inches, and that will leave a 9-inch waste, and that's not one of feasible widths available for us. So that's the second pattern. Now we can also, instead of 15 inches, okay, for the same 12 inches, we can accommodate a 20-inch width. That will be a different pattern, will give you 4 inches of waste. Okay, and then we can also do 3 of 12 and 1 of 24. Okay, now we cannot do 3 of 12 and any or 30 or 40 because it doesn't leave more than 24 inches of waste. Okay, so now let's go down to 2 now. So we have done up to 3, so let's do 2. If we do 2, how many 12 inches, 15 inches can we cut? Cut 2 15 inches, that will leave us a waste of 6. Next, we have to decrease the 15 inch by 1. Okay, so now we fixed 2 here, then we need to exhaust all possibilities here. So next is if we cut 1, that will leave us 21 inches, so that would be the next pattern. So now with 2 and 1, is there any other pattern possible? No other pattern is possible. So we go down to 0. So if we go down to 0, how many 20s can we have? 120, but if you leave 120, then we could do one of this, and that would be the same as the previous pattern. So 20 is not going to give us 212 and 120 is not going to be a unique pattern. It's going to be the same as pattern number 6. So now here if you do 1, that will leave us 12 inches. That will be like 3 and 1. So that's not a unique pattern either. We can do a 30 inch. So that will give us 6 inches. So now can we do anything more? No. So that's that. So now we come down to 1 12 inch. So if we do 1 12 inch, how many 15 inches can we do? Maximum 3 15 inches. Okay. So now we do 1 and 2 15 inches. Well, 2 15 inches leaves 18 inch, which means that we can do 3 15 inch, will be the same as the previous one. So 2 is not going to give us a new unique pattern. So we have to go down to 1. So if you do 1, then we can do 1 20 inches. That will leave a 13 inch, which will mean that you can do 2 12s. So that's not give us a unique pattern. So 20 is not going to give us a unique pattern. So there's 24. That's good. So now we will come to 0 here. So 1 of 30. So that's good. Now 1 and 1 is, you can't have a 40, so that's no good. Okay, next is, now we go down from 15 to 0, from 1 to 0 for 15. So in that case, we can do 220. Now what about 120 then? So if you have 120, then we can do 124. and 30 is not possible, so that's not going to be possible. So we'll do 1 of 0 of that, and how many 24s we can have? 2. So like, so that's 48, so we can have 2 of those. Then you have to go 1 and 1. 30, no, that's not going to be a unique pattern, so now we go to 30, and if you did that, then that's going to be the same pattern as before, which is 1 for 15, so that's the same pattern like number 9. So that's not possible, so that one is okay. So now we have exhausted all possibilities with it, starting with 12. Now we're not going to have any 12 at all, so if we have all of them 15, so that will give us 4. Then we can't have 3 because that would be same as 4, so we have to go down to 2. And 20, so don't jump to 30 right now. Okay, if you have to do it in a systematic way. So if we can have 1, so 2, and now 0 here. Can we have 24? Okay, so that's good. So 2 and 1, so that's good. Now we come down to 1 here, 1 and 2, 1 and 1 and 1, 1 and this will be 2. 2 is not possible. So if you have 1, okay, so that's not possible either. So we have to go. That again gives us a 15, which is one of the previous cuts. Okay, now that is good. So now we come down to 0 here. So how many 20s can we have? 3. Now you can't have 2 because that would mean another 20, so you have to go down to 1. And you can have, no, 124 is not going to do it. 2 is not possible, because if you do 1, that will leave us 16, which will be like 15 can be cut from that. Now 30 leaves us 10, so this is good. 1 and 140, so that's good. So now we are done with all the ones here. So now 24, how many you can have? 2. Okay, if you do 2, then that leaves us a 12, which is one of the previous cuts. So we have to go to 1 and 1, so that's good. Then we have 1, and that leaves us 36, which is the same as the previous one. So here if we do 2, that's good. Then if you have 130, so that will be the same as 2 30s. And if you have a 40, so that will be same as 40 and 20, which is the previous cut. So there are no more unique cuts possible.